Today we're going to take a look at definite integrals and the fundamental theorem of calculus. The fundamental theorem of calculus states that if a function f is continuous on a closed interval from a to b, and capital F is an antiderivative of the function on the interval from a to b, then the integral from a to b of f of x dx is equal to capital F of b minus capital F of a. So the answer here is going to be a number. For our first example, we're going to look at the integral from 1 to 4 of 3x squared minus 2 dx. So we're going to pretend like the 1 and the 4 aren't there to begin with, and we're going to find the antiderivative of 3x squared minus 2 using the power rule. So this is going to be equal to 3x cubed divided by 3 minus 2x. And then instead of writing a plus c at the end, we write a vertical bar and we write the two numbers, the 1 and the 4. Now if I simplify that, what I really have here is x cubed minus 2x, and then this means evaluate from 1 to 4. So that means 1 is a and 4 is b. We're talking about on the interval from 1 to 4. The fundamental theorem states plug in the b value first and get a number for that. So we do 4 cubed minus 2 times 4. And then we subtract the function evaluated at the a value, 1. So I do 1 cubed minus 2 times 1. So that's going to give us 64 minus 8 minus 1 minus 2. So 64 minus 8 is 56. So I have 56 minus negative 1. Our final answer here is the number 57. We'll talk about what this number represents in a minute. Take a look at the next example. We're going to find the antiderivative of 4x plus 7 evaluated from negative 3 to 2. So, again, using the power rule, I'm going to have 4x squared divided by 2 plus 7x, and we're going to evaluate from negative 3 to 2. So that's equal to 2x squared plus 7x from negative 3 to 2. And again, the 2 at the top is the b, and the 3 at the bottom is the a. So now we're going to have, plug in the 2 first, 2 times 2 squared plus 7 times 2 minus, now plug in the negative 3, 2 times negative 3 squared plus 7 times negative 3. If you go through and evaluate, you're going to end up with 8 plus 14 minus, let's see, negative 3 squared is 9, 9 times 2 is 18, minus 21. So we have 22 minus negative 3, which is 25. So what do these numbers actually represent? Let's take a look at their graphs. The first one, we were looking at the interval from 1 to 4. So when I look at the graph of the function, find x is 1 and find x is 4. If I draw lines at each of those up to the curve and then shade underneath, the number that I got corresponds to the area under the curve on this interval. Area is equal to 57 square units. for the second example, when we had 4x plus 7 in the integrand, we were going from -3 to 2. So if I draw vertical lines there, I want to shade under the curve. Now, shading under a curve is defined as shading between the curve and the x-axis. So the part on the right is this big triangle, gets shaded in. And then the part on the left is this little triangle. So now that we have the shaded, we had the area was equal to 25. But if I look at the two triangles, it's kind of confusing as to how the 25 comes to be. So what does this number really represent? The value from the integral of f of x dx over an interval from a to b gives you the net area under a curve which means between the curve or graph and the x-axis. Over the interval from a to b. If the net area is negative, then there's more area below the x-axis than above. And therefore the opposite is also true. If the net area is positive, then there's more area above the x-axis than there is below. So now the last thing we need to do is talk about, well, what happened to the plus c? Every integral problem we have done so far has had a plus c in it. What happens to it? So let's say we have a generic antiderivative from a to b of some function f of x dx. Before we would write that that was the antiderivative capital F of x plus the constant of integration, but now we evaluate from a to b. Plug the b in first and the a in second, and you get f of b plus c minus f of a plus c. And now you should be able to see that the c's are going to cancel off. You're going to get capital F of b plus c minus capital F of a minus c. And therefore those two c's eliminate each other off, and you get the fundamental theorem, which states the integral is equal to capital F of b minus capital F of a. We will take a look at a few more examples in class tomorrow.